Hello, my name is Punyapa Titichoatrattana. My nickname is Spoon. Came from 1103, and today I'm gonna talk about the chapter 10 of the physics class, which is going to be the work, power, and energy. Okay, first let's get started with the chapter 10, work, power, and energy. Firstly, we should have know what is work first. Work is when a net force is exerted on an object while the object moves at a certain distance. It is mean that the object acceleration and velocity is increased. It can be applying with the sigma F equal to ma, which we previously learned about. The formula would change to be W of work is equal to force times distance, or it can be converted to 1/2 times mass times by the velocity final, power by 2 minus by 1/2 mass times by mass and times by the velocity initial power of 2. This formula is when the constant force exerted in the direction of the motion, and when the force is applied to the displacement, it is work. And the SI unit of the work is joule, or J is actually equal to 1 N times M. And work is also can use the formula of Ft cos theta. Here's the example. It is the pictures of the visuals of the person who pushed the car in the angle of 25. We can draw the graph like this, and this is the y-axis. There's an x-axis. There's a force that exerted on it. The force is equal to 200 Newton, and the angle that it takes on is 25, so we can use the formula of W equals to Ft cos theta. The F is going to be 200, distance going to be 5, and cos theta is going to be cos 25, and the final answer would be work of this visual is going to be 906.3 joules. So let's move on to the energy. Energy is the ability of the object to produce a change in itself or others. We also have to know what is work energy theorem. The work energy theorem is when the work is done on a system and the result is change in the system energy. Energy is also measured in joules, and the relationship between the work's energy is that through the process of making work, energy can move between the external world and the system. If the external world do works on the system, the work is going to be positive and the energy for the system is going to be increased. But if the system does work on the external world, the work is going to be negative and the energy inside the system is going to be decreased. Energy resulting from the motion is called kinetic energy, or Ke. The energy due to the motion of the system centers of mass is called translation kinetic energy, which is going to be the formula in this one, which is Ke trans is equal to 1/2 but times by mass times by the velocity power of 2. Let's move on to a power. Power is the rate at which the energy is transformed. It can be right in the formula that is power is equal to delta energy over T. E is stand for the energy and T is stand for times. And the SI unit of the power is watt, or W, and 1 watt is equal to 1 joules over second. And when force and displacement are in the same direction, the formula of the power is going to be F times D over by T. F is force, D is displacement, and T is time. Because D over T is the speed, this formula for the speed, so the formula is actually the speed times by the force, and it can be right as the Fv. Okay, so now there's time for the essential question. The first one, what is work? As I mentioned before, work is the force applied through the displacement. The second one, what is energy? The energy is the ability of the object to make change on itself or others. And how's the work and energy related? As I mentioned before, that the If the external world does work on a system, the W or the work is going to be positive and the energy inside the system is going to be increased. But if the system does work on the external world, the work is going to be decreased and the work is going to be negative and the energy inside the system is going to be decreased. Okay, for the last question, the last essential question. What is power and how it is related to work and energy? So power is the rate of energy that is transformed, and the formula of it is the P is equal to delta E over T, or P is equal to F times D over T. And that's the end of the chapter 10. Thank you for listening.